I'm Dr. Roger, and today I'm looking at differential equations, in particular a first-order, nonlinear, ordinary differential equation, and this particular one is homogeneous. We know it's first order because the highest derivative is the first derivative. It's nonlinear because we have y squared, and we recognize this as homogeneous, homogeneous, or homogeneous. 5 syllables, and some math professors get irritable if you mispronounce it, so try to pronounce it correctly. We know it's homogeneous because the x squared is total degree 2. The xy, x to the first, y to the first, 1 plus 1 equals 2, total degree 2. Y squared is degree 2, and the negative x squared is degree 2. Everything has the same degree, so this is homogeneous. For some functions that are not polynomials in several variables, you can also check it. If you multiply through by 1 over x squared, that gives you 1 plus 3y over x plus y over x quantity squared minus dy dx equals 0. So that's dy dx equals 1 plus 3y over x plus y over x squared. If you can write dy dx equals some function of y over x, then your ordinary differential equation is homogeneous. Many of these turn out to be polynomials in several variables, but in general, anything that can be written as a function of y over x is homogeneous. Once you've classified it as homogeneous, and the hard step in first order is classifying, because classifying the type tells you the method you're using. For homogeneous, we'll use the change of variables y equals vx, or equivalent y over x equals v, and the product rule gives you dy equals x dv plus v dx. And you will need to use this for the dy in your numerator here. So the left-hand side is 1 plus 3y over x is 3v plus y over x squared is v squared. And the right-hand side equals x dv plus v dx for dy, and that's over dx. I can separate the terms and then subtract the v, but I prefer to cross multiply because we often do homogeneous by cross multiplying. 1 plus 3v plus v squared dx equals x dv plus v dx. I'm going to subtract v dx from both sides. So that gives me 1 plus 2v plus v squared dx equals x dv. The purpose of this change of variable, y equals vx, is to make our homogeneous equation separable. We see that it is separable if you use this change of variable and end up with something that's not separable. Either your initial equation was not homogeneous or you made an arithmetic error. Check and see which it is that happened. Now at this point, since it's separable, I'm going to divide by x to move all my x expressions to the left. I'm going to divide by 1 plus v quantity squared to move all my v stuff to the right. So this is dx over x equals dv over 1 plus v quantity squared. My variables are separated. I can integrate both sides. Integral dx over x equals the integral d. Let's write it with 1 plus v to the negative 2 dv. Left-hand side is natural log x. I'm going to put in the absolute value. Equals negative 1 plus v to negative 1 plus c. This is not the solution to my original equation because this doesn't have a y in it and the original does not have a v. So let's return to y. ln x equals negative 1 plus y over x, the negative 1 plus c. Common denominator on the right. X over x plus y over x. So that is negative x plus y over x to negative 1. If I flip this fraction, execute the negative 1 exponent, and then move it to the left, I have x over x plus y plus ln x equals c. This is not solved for y. It can be solved for y, but in many cases for differential equations, you'll write your solution solved for c. If I wish to solve for y, I'll get this fraction by itself, move the other two to the other side. So that's x over x plus y equals negative ln x minus c. Let's flip both sides. X plus y over x equals 1 over minus ln x minus c. X over x is 1. I'll subtract 1 from both sides. Y over x equals 1 over this ugly denominator minus 1. Multiply both sides by x. Y equals x over minus ln x minus c minus x. I could combine them into a single fraction, but I've solved for y and that's more than sufficient. This is homogeneous first order ordinary differential equations. The word homogeneous has a completely different definition for second order and higher order, and we'll look at that another time. Come back soon for my next video. With math, there's always more.